Hello everyone, my name is Csaba Fitzl and welcome to my talk about XPC exploitation on macOS. A few words about myself. I'm working right now as a content developer at Offensive Security. That's the company behind Kali Linux and the OSCP or OSCE certifications. I used to be a red and blue teamer before that for about 8 years, and recently in the past 2 years I started to do macOS vulnerability research. I have a wife, 2 kids. I love to do hiking and also doing yoga. So what I will talk about today is again XPC exploitation on macOS. First I will introduce it, then talk about what is XPC, then talk about the XPC APIs macOS is offering, and then talk about all the exploit scenarios we can face and trying to exploit XPC services. One of them is the Apple sample code. And then we will look through the vulnerable clients, incorrect client verification, bit process ID reuse attacks, and at the very end, I will also talk about how we can prevent these attacks and how we can actually make a secure XPC service. So just a few words about how this entire research or topic started with me, at least. So last year I read an excellent article from Phil Stokes, who is a malware researcher at Sentinel-1. His article was about spoofing privilege helpers to gain root. And in the middle of the article, he had a sentence that abuses of this trust mechanism between parent process and privilege helper tool are possible. And for some reason, this caught my attention, and I got really interested in these privilege helper tools. What are these? And I was like, yeah, please tell more. Well, unfortunately, Phil's article was about something else, but I started to dig up lots of stuff about XPC and XPC exploitation. So that time, last year, this was about a year ago, this is what really was out on the internet. So there was this article, the story behind CV 2019-13013, which was an exploiting Little Snitch. Then was an excellent presentation from Tyler Pohan at OffensiveCon last year in February about exploiting XPC services. Then, of course, we had Apple's even better authorization sample code for how to code privilege helper tools. Then a few talks at the Apple Developer Conference about XPC, but that's mostly about how to develop these services. And actually there are more resources, but these were the ones I found that time and started my journey on exploitation. And then profit. Like, honestly, these bugs are little everywhere. Like, it's all around, and you will find these XPC bugs on almost everywhere, really. Like, I think like 80-90% of all the third-party tools I audited were vulnerable, including like VMware, Microsoft, Adobe, Proxyman, F-Secure, and just many, many more. Really bugs everywhere. And really, this is why I wanted to do this talk. These bugs are all over. Very few people actually exploit them, and actually even macOS research is not that widespread. there is no clear guidance from Apple how to make a secure XPC service. And even if there was, unfortunately, there is no secure public API from Apple for really making a secure XPC service. We will see that unfortunately to make it really secure, we have to use private APIs. But if we use private APIs, for example, you cannot load any application to the Mac App Store. Also, if that API changes in the future, you need to support and maintain your application. So that's a problem. It's very easy to make an error during making of the service, and it's also very easy to exploit. So, and I think we are in the golden ages of third-party XPC exploits. I think it will take a while this message gets to developers. Since last year, there were a couple of other talks about exploiting XPC, and more people try to spread the word how to make a secure XPC service, but it will take time. So if you want to do this, go out and you will find plenty of vulnerable applications. So, but what is XPC? I keep talking about XPC here. It's an interprocess communication. So macOS-based IPC is based on Mac messages. At the core layer, everything is going through Mac messages, including the kernel itself. Now, XPC is an IPC built on top of Mac messages to make it much more simpler. And it was introduced in 2011. And it has a really simple, easy to use API. Compared to Mac, if you ever had to deal with Mac or reverse engineer Mac API, it's really clean and nice and easy. And now, what is XPC, what it stands for, really no one really knows. To best of my knowledge, Apple never really told it. So it could be like a xenomorph patch symmetry or extended process communication. Probably the second is more likely, or it could be cross-process communication, or yeah, anything you can come up with. So the core idea behind XPC, why Apple made it, the main idea was to have an application and divide it into separate components. And each of these components are running as its own process, which gives you better security and better reliability. And all the app components talk over XPC in between them. So, and each of the components will have the least privilege it requires. So, for example, Safari, the web browser, we have a component which is the rendering service, and it will not have any network access because it doesn't need. It just needs to transform the HTML page into a visible website. And basically what Safari can do, the main application can send over all of the website content. The renderer will process it and send and display it. It doesn't need to have network access. So if you, for example, find an exploit in that service, you are contained inside the renderer process space, which is really restricted. And if you want to go further, you need to break out of the sandbox. So it's another step. Or if it's crashing for any reason, then the application can still run. It's enough to restart the actual XPC component. So a crash in one of those doesn't affect the whole application. And the same for any vulnerability. And the components itself, they don't have to be on different privilege level. So the original idea was that same application, same user level, same privileges run at the same level. But then we have this concept of privileged helper tools, which was before XPC was introduced. So let's say you have an application that Some of its component requires root access to the device, like installation, updates, accessing location where only root has access, or whatever really, or changing system settings that only root is allowed to do. You need the idea is to have a privilege helper tool, that's the name, of these that we run as root, and your main application can talk to this privilege helper tool. Now, it can happen over XPC or over anything else, like it can happen over Mac messages or distributed objects or whatever really you want. These days, XPC is the most common IPC for everything, really at the top. So I think like 90% of the cases, if you have a privilege helper tool, that we use XPC. And these tools by design run as root. And they advertise the actual service to Mac service names. Now, the problem is that by default, any known sandbox application can talk to these privilege helpers. So macOS doesn't restrict the client to the same developer ID or the same code signature by default. So anyone can talk to them. Now, actually, Apple or macOS does restrict if if you are using application components, which is inside the application bundle, but those are not Mac services advertised globally on the system. So by default, we can talk to these helper tools. And if we can talk to them, we can run privileged actions. And a full privilege escalation is really depending on the function offered by the privilege helper tool. So because everyone can talk to these tools, it's up to the helper tool to actually verify who is connecting to it and who is performing the action. And this is where all the bugs are. So let's cover quickly the XPC APIs that are out there. The first one, when XPC was introduced, was the C API. This is a very short sample code on the screen from a client. So initially, we create a connection, an XPC connection T variable, then an XPC object T type variable MSG, which will be the message. Now, the message in XPC is a dictionary. It's always a dictionary. And actually, it's an NS dictionary. So we create an empty dictionary, and then we add keys and values to it. In this case, we add strings like value and value2, but we can add other ones as well, like arrays or integers, strings, dictionaries. It's very restrictive what we can add. We cannot just do every type. There are about 10 types of different objects that we can pass. The next one is to look up the service with XPC connection create Mac service. We give it the com_some helper. That's the name of the Mac service we are looking for, and we are trying to connect to it. This is where the connection is established. So if the XPC service will not accept us as a client, we will fail here. If this goes through, then everything is good, at least on the first step. Then we set a connection event handler that is required as per Apple, and then we resume the connection. And basically the last step remaining is sending a message over XPC. So it's really clean and simple, and the API is very, very similar on the service side. So there is like XPC dictionary get string, and so on. So it's really easy to reverse and see the code. Now there is the NSXPC API, which is part of the Cocoa framework, and it will use the C API underneath, but it allows another layer of abstraction. So we can define a protocol, which is an Objective-C concept. Basically, it's not a class, but it's a group of function that the class can implement. And the function will have a definition, what's the return value, and what argument it expects. In case of XPC, the methods cannot return anything. Well, they can return a reply, but they don't have a classic return value. So we define a protocol on both sides, both the client and the service side. The service will have a class which will implement the protocol, and that class will serve the XPC connection. On the client side, we just define the protocol. Then again, we define the service name. Then we do an NSXPC connection. Init with mock service name, we connect to the service. Then we set the remote object interface, and here we create an NSXPC interface with the protocol definition we have. In this example, it's the helper protocol. And then we resume again, and then we create a remote object proxy, and basically that's it. And then we can call these functions over XPC. So we got back an object as a return value, and we can basically simply call the run app method in this case on the object, passing any arguments. We are still restricted to the same types what XPC can use, but this allows another layer of abstraction. So we can basically call functions, and it's more flexible than the C API. And it's also very easy and clean to reverse. Now, what are the common issues with XPC? Again, all of the issues are around who can talk to the actual service and who cannot. So let's start with the even better authorization, which is Apple's sample code for privileged helper tools. It's really old, like really, really old. And it's not better, it's actually the worse. Why? The XPC service in this sample code will accept everyone. So by default, you can connect to the privileged service. Now, then the service itself tries to limit function based on authorization. Now, when you do authorization on the XPC service, you need to pass an authorization reference from the client. But the client, at first hand, it will only set up an empty authorization, which anyone can do. So you pass that empty authorization, and then the privileged helper tools will try to obtain the rights for the client. Now, depending how the authorization right is set up, you might be granted authorization or not. There are two main cases. One is the rule class allow, which means, yeah, granted. So it's like it's not there. It will be granted. And then there is another one, authenticate as admin, what will happen, the user will get a prompt that the application that is trying to talk to the XPC service is trying to do system modification. Now, if you make a nice icon or name your application look like another one, no one can tell that who is making this request. Like, I think macOS users are so used to these prompts that they will happily authenticate. So in my point of view, this is not really a restriction. Like, yes, some users will stay alert and they will not type their password, but I think many will. So I don't really consider this as a security protection here. And yeah, these are the problems that what we just discussed. Now, the example for this I have is Proxyman. That's a small application monitoring network traffic. It has a privilege helper tool to change the proxy settings. It cannot do anything else, so it didn't have like a full privilege escalation vulnerability. It just gave you access to some system configuration. And the developer used Apple sample code for this, and the authorization right was set to allow. So basically, you were just granted access. Now, really kudos to the developer, because when I reported it, he fixed it in a few days. And I think that was between like Christmas and New Year's Eve, or that time period. So it was really quick, responsive, and really fixed it really quickly. So let's see a demo of this. So here I have the application installed. This is my network connection. The proxies, this is set. So let's go back and remove the proxy configuration. Let's apply it. Let's just see that it was removed. Yeah, it's not set. And let's lock it. So if I go back now, I cannot change the proxy. Now I can just run my exploit. And let's see, it's not, there is some race condition in this exploit. So let me run it a few times. But yeah, now it's set. So we have proxy enabled for localhost 3333. And again, just to show, we did run it as a regular user and not as root. So this was Proxyman, again, using Apple sample code, and there are many applications using Apple sample code. And again, I think this is a problem originating from Apple side, because they are clearly providing a really bad example. And if I were a developer, I would go and trust what is provided on Apple's website, which is actually not good. So moving on, vulnerable client. So let's say the XPC service properly validates the client, which is many times not the case as we will see, but let's say it does it. If our client is vulnerable, then it doesn't do code injection, then it's worthless. So basically, when can we do code injection on a client or on an application? So there is no hardened runtime set. There is no library validation set. If these two are not set, you can just inject any dilib to the application and run inside the context of the application. And if the XPC service is restricting access to its own client, as we could inject code, it's not important. But if it's signed with hardened runtime, which actually these days is a requirement because notarization service requires hardened runtime, and if you don't notarize an application these days, then gatekeeper will not like you. But if you have hardened runtime, but have the disable library validation, or have the get task allow exception entitlements, this means that these basically lift up some of the restrictions, and you can again inject code into the application, either through a dilib or through task force. So when we set up an XPC service, we need to ensure that our client who we are expecting to work with is hardened against code injections. Again, if it's not done, then the client verification is completely pointless. And again, anyone can talk to the service. Now, probably one of the other most common issues is the incorrect client verifications. This is the step which, even if you try to get it right, it's very easy to miss some small pieces. So let's say the XPC service properly verifies the signature of the connecting client, but it doesn't verify if the client is secure or hardened against injections. And that's a problem. Why? We'll see why. So what should be done to make it properly? So when client verification happens, the service should verify if the client is signed with a valid code signing cert, which is an Apple signed developer certification, if it matches the expected team ID, because if the team ID is not verified, I can just use any random application to again talk to the XPC service, and then either 3 or 4. So either verify that the client is protected against injection by checking the bundle ID and checking the minimum version of the client, which the developer knows that is not vulnerable for injection, or just take the entire code signing blob of the client and check all the code signing flags and all the entitlements that it's properly hardened. If we do all of this, then it's almost good. But so why is it a problem if we miss to verify if the client is hardened if we know that our client is hardened? Because if we take an older client, typically from the Mojave times, which wasn't a long time ago, like a year ago, that time hardened runtime really wasn't a thing. It was introduced in Mojave, so we can easily find an older version of the client which is vulnerable for injection. So we can take the old client, inject into the old client, which will satisfy the code signing requirements, and again we can talk to the helper tool. So an example for this is Microsoft Auto Update. They had a helper tool to perform some of the update activities, and they really verified everything properly. Like they checked if it's an Apple signed certificate, they verified the team ID, the bundle ID, except they didn't verify the client version, which basically meant that I could find an earlier version of Microsoft Auto Update, inject my code into that, and make a copy with the application. So this service, the XPC service, offered a function called create clone from app, which basically allowed me to copy a file from one place to another with root privileges. So what I did, I basically took a plist file and moved it to the launch daemons directory, where if I reboot the Mac, that plist or the code inside the plist will be executed as root. So this is like a full privilege escalation. Again, how it looks. So again, we have Microsoft Auto Update installed, and I have here an old version of the client application as well downloaded. So if I check the code signing properties of this app, we can see that it's not hardened. So I can just freely inject to this application. So I will inject a dylib through the dyd insert libraries, environment variables, and this dylib is basically, we do what I said before, it will copy a plist into the launch daemons directory, but let me show you what's in there right now. So we can see that we have the Proxima, VMware, and Microsoft helpers in launch daemons, and if I execute the app, so injected code, auto update pops up. Yeah, I don't want auto update. And if I check now what's in there, we can see that I moved a plist file there. And if I print this out, so basically it will execute this command upon reboot. Let's move on. And the last typical issue with client verification is the use of process ID for verifying the client. So if we use process ID, that's bad. Why? There are two problems with it. The range is really small for process IDs, so it can be easily reused. And the other one is that you can spawn a new process inheriting the process ID of the parent. The solution is to use audit tokens for verifying the client, but unfortunately that's private API. So you either do an application with public APIs or potentially run into bugs with or issues with a later macOS update where Apple decides to change the private APIs for audit token. Audit token is secure to identify the client, and it's not vulnerable to reuse attacks. Well, since 2017, when Jan Beer found out that it's not better than a process ID, you can read up the details on Google's websites. It's really nice. Again, private API, it's a problem. Now, how the generic exploitation looks like, in this case, we make a client, any client, and we start with sending a message to the XPC service. Then we spawn a new process with these flags, and we start the real client with the spawning, which will get the process ID of the parent. So when the XPC service gets the message and checks the signature of the spawned process, that time the real client will run and the signature will be just fine based on the process ID. And although it's a race condition, because you need to spawn a new process faster than the XPC service to process the XPC message, but it can be easily win, mostly because the XPC services are not running by default. So when you send a message, macOS will start it up and then keep it live for a time period. But when we first talk to it, it needs to set it up, and that takes slightly longer time than spawning a new process. So again, it's an easy to win race condition. An example for this, VMware Fusion had a bit reuse vulnerability, so you can talk to the VMware helper tools because all of them were affected
with this kind of attack, and you could do privilege action execution, or someone actually found the full-blown privilege escalation using this vulnerability. But how to do it securely? Hopefully I covered all the details of this during the talk, but let's try to summarize it. So first, the client, it has to be signed with hardened runtime or library validation. And it mustn't have any of these entitlements, the get task allow and disable library validation. If any of these two present, it's game over. And it also shouldn't have any script files, because when we start an application on macOS, the code signature of script files will not be verified upon every execution. So you can easily put your own code into these script files. So basically all Electron apps are bad from this point of view. And the XPC service side, so when we hit the should accept new connection on the XPC service, which is basically deciding if the service accepts or not the connection, it should first verify if it's a valid certificate from Apple. If it's signed by your team ID, then potentially verify the bundle ID you expect, and either verify the software version with the bundle ID, or verify that the client is hardened against injection attacks. So it has the hardened runtime or the library validation flag set and doesn't have those entitlements. And to do all of this, it has to use audit token. So if all of these are met on both the client and on the service side, then it's secure and it should be fine. Now, if any of these are missed, it's vulnerable. Now, and this is why we have many vulnerable XPC services out there, because it's really easy to miss one of these steps. Conclusion, there are still a lot of bugs out there. There are not many people exploiting XPC services. So if you want to find ODAs, potentially participate in bug bounties, go out, spread the word, educate app developers. It's really everywhere, unfortunately. And questions will be answered later on the chat. And a few more resources if you are interested in. Then there were 2 talks at Objective by the Sea this year about XPC. Then, as mentioned, Tyler Pohan had an XPC exploitation last year, and then Jan Beer had an IPC exploitation talk back in 2015. There are also numerous blog posts these days, both from Reggie or myself on the web, so you can go and read them. There are plenty of POCs and exploit details out there. And if you know application Mac app developers, then point them to these slides and educate them. Thank you for listening.